Welcome to This Explainer. When we look up at the night sky, it kind of feels like everything is just perfectly still, right? Like it's eternal. But the reality? The cosmos is insanely dynamic. Today, we're diving into one of the absolute most violent events in nature, galaxy mergers. And we're going to start with a scenario that hits, well, literally right at home. Seriously, think about it for a second. What actually happens when two entire galaxies, each packed with billions of stars, just crash into each other? I mean, it sounds like pure science fiction, doesn't it? But this is a very real, unbelievably violent cosmic event. We're talking about structures so massive that their gravity literally reshapes the space around them. And understanding this gives us absolutely crucial clues about how our universe actually evolved. Part 1. The ultimate cosmic collision. The impending fate of our Milky Way. Because, hey, we aren't just passive observers in this cosmic dance. We are very much active participants. Right this second, our own Milky Way and the neighboring Andromeda galaxy are hurtling straight toward each other. In roughly 4.5 billion years, that initial collision is going to begin. Fast forward through another 2 billion years of cosmic choreography, and simulations show these two grand spiral galaxies will completely fuse together, forming one single, massive elliptical galaxy. Now, when you hear the word collision, you're probably picturing stars smashing into one another like some giant cosmic demolition derby. But actually, it's much more like a ghost crash. Because of the unimaginably huge empty voids of space between them, individual stars almost never hit each other. No way. Instead, it's the massive clouds of gas, the cosmic dust, and all that underlying dark matter that aggressively tangle and completely reshape the galaxies. Part 2. Anatomy of a merger, creating chaos from order. So, if the stars aren't physically slamming together, what is actually causing the damage? Well, as these galaxies merge, their collective gravitational pull starts fluctuating wildly. It triggers this process with a great name, violent relaxation. Picture two disk galaxies. Normally, their stars rotate in a highly organized flat plane. But violent relaxation permanently scrambles all those neat, orderly orbits, transforming that organized motion into a chaotic, random swarm. The stars literally lose all memory of their prior paths. It's a complete reset. Part 3. Starbursts and dead galaxies, the engines of creation and quenching. All this gravitational chaos forces giant molecular clouds to plummet toward the center. And the original ingredients of the galaxies totally determine what happens next. In what's called a wet merger, that's between gas-rich blue galaxies, the shockwaves compress all that gas and trigger massive, furious star formation. It's explosive. But on the flip side, in a dry merger between gas-poor red galaxies, there's just no fuel. No new stars are born. The galaxies basically just mash their existing mass together into a larger, dormant structure. To really put the sheer violence of a wet merger into perspective, let's look at our own neighborhood again. Our relatively quiet Milky Way creates, maybe 2 new stars a year. 2. But during a major wet merger, that rate absolutely skyrockets. We're talking about forging thousands of solar masses worth of new stars every single year. It is a literal engine of creation. But here's the catch. This intense burst of creation comes at a steep cost. The furious star formation burns through all that available molecular gas so incredibly fast that it completely chokes off or quenches any future star creation. The galaxy enters what we call the post-starburst phase. Basically, it burns brilliantly, exhausts all its fuel, and then abruptly dies. And this rapid quenching is exactly why ancient mergers left behind those massive, gas-poor, dead elliptical galaxies we see scattered out there today. Part 4. Waking the supermassive monsters, igniting the cosmic void. Right before all that gas is entirely consumed, though, it fuels a much darker, hungrier force hiding right at the center. The gravitational chaos from the collision drives vast amounts of gas inward, and that wakes up active galactic nuclei, or AGN. These are extremely luminous galactic centers, and they are powered by gas actively falling onto totally dormant supermassive black holes. The friction of this cosmic feeding frenzy causes the core of the galaxy to blaze with just unbelievable light. And this is a real game changer for our understanding of the universe. Recent analyses have confirmed a powerful connection. The brightest, most energetic supermassive black holes in the cosmos are almost exclusively awakened by these violent galactic collisions. It turns out mergers are the definitive trigger connecting the evolution of a galaxy to the evolution of its black hole. Part 5. Simulating the universe, decoding the cosmic dance. Now, you might be wondering, how do we actually know all of this? I mean, these events take billions of years to unfold. Well, it starts with massive, wide-scale observation. Right now, the European Space Agency's Euclid Space Telescope is mapping a full third of the entire sky in 3D, peering back 10 billion years into cosmic history. And with absolute mountains of optical and near-infrared data pouring in, researchers are deploying advanced machine learning to instantly classify galaxy shapes and spot these ancient mergers at scale. Then, by pairing all that incredible telescope data with incredibly complex computer simulations of gravity and fluid dynamics, scientists can actually slice up a multi-billion-year collision into precise, predictable stages. They can calculate the exact timescales. We're talking from the first pass, which happens over about 1 billion years, to their maximum separation, all the way to the catastrophic final merger event, and finally a long post-merger relaxation phase that spans nearly 2 billion years on its own. It's like putting together a giant puzzle across deep time. So think about the violent relaxation, the massive starbursts, the awakening of those supermassive black holes. These aren't just distant, abstract concepts. The very atoms making up our world, and literally making up our bodies, were heavily influenced and forged in the chaotic fires of ancient galactic collisions. We are, for sure, the direct descendants of this cosmic violence. So if that's true, how does that change the way you look up at the night sky? Keep looking up and keep questioning our incredibly dynamic universe.